One of the challenges encountered during the course of a design bid project is how to manage the design process to ensure the final design cost doesn't exceed the planned bid cost. Our goal was to come up with a method that would help us avoid late-stage surprises when redesign is very costly, and be able to evaluate the design cost trends at any point during the design and compare against the planned bid cost. The result was a software tool that utilizes Bentley's iModel technology to achieve the goal. We found there were beneficial byproducts of using the DMBC tool. We're able to more closely monitor design progress compared to schedule. We can extract components from an iModel and pass them on to SpecWave, which automatically generates specs only for components that exist in the iModel, resulting in both cost savings and less confusion in construction. And we have a simple process for generating standard schedules and lists. Here is the workflow. Design work commences in the model until a specific milestone is reached, at which point an iModel is generated and loaded into ProjectWise. After a review is conducted, the iModel becomes the baseline for comparative purposes. At the next review milestone, the DMBC tool can be incorporated. DMBC uses iModel input from a previous milestone as a baseline and compares it against iModel data generated at the current milestone. DMBC then generates reports and lists, and at the appropriate stage, the lists go off to SpecWave for automatic spec generation. To demonstrate how this works, I've checked out a previously created baseline iModel from ProjectWise and a design model which has been edited since the baseline iModel was created. Here's the original baseline iModel where I've isolated on a single process line. Here's the current design model showing that same process line which has been edited. The next step is to generate an iModel from the design model, which I do by selecting Publish iModel and selecting OK. With the new milestone iModel generated, I can now run the DMBC tool. I'll first select the baseline iModel, followed by the milestone iModel. And then I simply select Create Report. Results are presented in tabular format with tabs for various display options. The brief report highlights just the deltas between iModels. The data is segregated by line number and can be further filtered by unit, system, area, or spec. Columns are displayed for each piping component, with the deltas shown between iModel 1 and iModel 2, either in linear units for pipe or in total quantities for components. Decreased values are shown in red and increased values are shown in black. The Detailed Report tab shows additional information with color-coded column headers for each component type, the blue representing iModel 1, the green iModel 2, and red the deltas between the two. The valve list contains a complete extraction of all valve data from iModel 2, which is the milestone model. The valve list data can be exported to an Excel workbook, which can be used by SpecWave for the automatic generation of valve specs for all valve types present. Currently, that's all the capability built into this tool, but in the future, we expect to be able to expand the capability of DMBC to show the location of an item selected in DMBC by automatically highlighting the component in the original iModel. We also expect to be able to use color coding to identify differences between the base iModel and the milestone iModel. And then we also will be able to capture commodity code information from the iModel and feed it into cost estimating software, including implied items. Lastly, here are some of the benefits derived from utilizing the capability in the DMBC tool. We can find and correct deviations from plan earlier in the design, improved profitability, keeping projects on schedule, verifying that work commences as planned, and reducing our risk exposure. The above benefits result in smoother running, better executed projects.